The force of gravity between the moon and an object near its surface is much smaller than the force of gravity between Earth and the same object near Earth's surface. A bowling ball with a mass of 7.51 kilograms is pulled downward with an unbalanced force of 12.2 newtons. What is the acceleration of the falling bowling ball on the moon? All right, our original formula is force equals mass times acceleration, but this time we are looking for acceleration. So I need to solve and rearrange this problem to solve for A, for acceleration. In order to do that, I need to get rid of the m so that I have acceleration by itself, and the m goes to the other side. Right now, it is being multiplied by the mass, so I need to divide by the mass to get rid of it. Or in other words, I need to do the opposite. And what I do to one side of the equation, I must do to the other. So mass cancels out on the right side, leaving me with acceleration equals force divided by mass. So now I'm going to plug the formula in. You always want to show your formula. Then you want to show the formula with the numbers and the units plugged in. The force is 12.2 newtons. Divided by the mass, always include those units, 7.51 kilograms. And when I enter that on my calculator, 12.2 divided by 7.51. I get 1.62, and I'm just going to round off to the tenths place. So I get 1.6 meters per second squared. Since a newton up here at the top, I'm going to change colors to show this. Since a newton is the same thing as a kilogram meter per second squared, the kilograms are actually canceling, leaving me meters per second squared as my unit, which is the correct units for acceleration.